I'm here at the NASA Langley Research Center's model shop to look into the design process involving models.
Hello, RJ. I read your friend's email, so I understand you want to learn more about making a model.
Yes. Now, we're doing an assignment on transportation and what it would look like in 100 years. Now, I understand that in the engineering design process that making a model is very important. I'm not exactly sure why.
Okay, say if you want to test your own design, would it be a good idea to just go and build it?
Probably not, because it'll cost too much. You don't even know if it'll work.
Exactly. What if your plane or car doesn't work properly? Then you will also risk losing a human life during the testing phase.
Wow, I didn't think of that. But why are the models so small?
When we build model airplanes, the engineer determines what scale is needed.
What is scale?
Scale is the ratio or measure between the size of the model and the full-size version. For an example, take a look at this F-18 model. The scale is 5%, which simply means it's 1/20th of the full-size airplane.
So if an airplane is 10 meters long and I want to build a model about 1/10 its size, then the model would be about 1 meter for a scale of 1 to 10.
Very good.
What scales normally used when building models?
Well, one rule of thumb to follow is that the smaller the scale, the less expensive it is to build, and the easier it is to modify. However, the size varies depending on the design and how the model is tested in the various wind tunnels.
Aren't all wind tunnels the same?
Not at all. We have 38 wind tunnels, and they vary in size, and they test different functions. Some tunnels are large enough to test a small airplane, while others are only a few centimeters in size.
Why does NASA build airplane models?
Here at NASA Langley, we conduct research on model airplanes in order to make them safer, quieter, energy efficient, and more environmentally friendly. We also want to find ways to make them less expensive to build and maintain. Using models make this research easier and less costly.
Wow, that model over there looks really cool.
It's called the Blended Wing Body, BWB for short. It's a futuristic airplane with a unique shape that will cause the entire plane to generate lift and minimize drag.
We learned about lift and drag in the case of the challenging flight. They are two of the 4 forces of flight. If you want to learn more about flight, check out the NASA Sci Files website.
Very good. And the design of this airplane is more efficient and will consume 20% less fuel while cruising at high subsonic speeds.
Wow. It looks like the wingspan on this is about 88 centimeters, or 0.88 meters, on a scale of 1 to 100. So the full-size version is going to be 88 meters across. That's one huge plane.
It would be slightly less than the length of a football field. It's being developed to carry 800 passengers, but recent studies have focused on vehicles in the 450 passenger class. This model here is expected to fly the year 2020.
2020? Let me see, I'll be about 29 years old.
And I'll be... never mind.
Thanks, Mr. James. Never knew models would be so useful.
You're welcome, and I wish you good luck on your assignment.
All right, bye.
Bye-bye.